Today's statistics topic will be talking about a few more discrete probability distributions. There are other probability distributions called geometric distributions. My course doesn't follow those, so if you need more information about geometric distributions, please feel free to head over to YouTube and just type in geometric distribution. My class, however, does cover a distribution called a Poisson distribution, so we will be discussing that in today's video. All right, a Poisson distribution is a discrete probability distribution, so not continuous, definitely discrete, and it must satisfy the four following conditions. The experiment consists of counting the times an event can occur in a given interval. The interval, very important. It has to be a certain interval of time. They will tell you in this 55-year period, in this 100-year period, in this, so they'll be very specific. The probability of the event occurring must be the same for each interval. And the number of occurrences in one interval must be independent from the number of occurrences in other intervals. And the fourth thing is that all of the probability will follow this particular formula. This makes sure that you know how to use your calculator. Make sure you know how to use your power button, and make sure you know how to use the base E button, and make sure you know how to use the factorial button, because you will need all three of those to complete this. And for most of my students, that seems to be the hardest part, is getting everything typed in the calculator correctly. So do make sure that you practice plugging in these values as we're going through the lesson, because you will definitely need to make sure that you can do that. All right, so first example, the mean number of accidents per month at a certain intersection is 3. What is the probability that in any given month, 4 accidents will occur at this intersection? Okay, so they're being very specific about the time interval. Okay, it's this given month, and that is important because we have to identify our interval. So the given month is important. We need to know that there were 4 accidents. So that is my x. My x is 4. And it says the mean number of accidents is 3. So x and mu are the two things that you must have for the Poisson. So again, the probability of x is going to be, and I'm going to write this down so that we'll walk through it. So it's going to be mu to the x power, and then you're going to multiply by that e to the negative mu power, and then divide by x factorial. So in our case, our mu is 3, so it is 3 to the 4th power, and then we're going to multiply that by e to the negative 3 power, and then divide that by 4 factorial. So practice putting this in your calculator, and when you put it in, you should get about 0.168. So make sure you practice typing that in your calculator, because it's going to be really important that you know how to do that, because otherwise you'll get the wrong answer. All right, second example. A population count shows that the average number of rabbits per acre living in a field is 3.6. So let's write that down. The mu is 3.6. What is the probability that exactly 7 rabbits, so my x is 7, are living in a randomly selected acre? All right, so again, we are just going to use the formula and plug it in. So probability of 7 is going to be, again, your mu raised to that x power, which is 7, and then e to the negative 3.6 power, and then divide that by 7 factorial. Put all that in your calculator, and again, you may need to practice, and you should get 0.0425 approximately when you round. And then again, just make sure that you're rounding the correct number of decimal places that your instructor or your homework software package is telling you to. All right, there have been 652 Atlantic hurricanes during the 118-year period starting in 1900. So from the year 1900 to 2018, there have been 652. So again, already have that very clear interval, right? That 118-year period. Find the mean number of hurricanes. Okay, so I need to find the mean first. They're not going to give it to me. Okay, there have been 652 hurricanes in those 118 years. So if you divide those two numbers, that should tell you the mean number of hurricanes per year, which comes out to be about 5.5 hurricanes per year. All right, part B. Find the probability that in a randomly selected year there are exactly 6 hurricanes. All right, so we need to find P of 6, which is going to be our mu raised to the 6th power times e to the negative 5.5 power, and then divide it by 6 factorial. So I'll put all that in my calculator, and that turns out to be about 0.157. So you have about a 15, almost 16% chance that there will be 6 hurricanes in any given year. All right, so they gave us a little bit more backstory in number 3. So it says in that same 118-year period, there were actually 16 years that had exactly 6 hurricanes. So if we take that 118 and we multiply it by that 0.157, that tells us that we, according to our model, had 18.5 years that had 6 hurricanes. Well, they said there was actually 16, so that's actually not too far off, right? We got 18.5 using the model, and the actual data was 16. So we aren't too far off. And you will notice that models aren't going to be perfect. They aren't going to be exact. And sometimes they can be very, very wrong. But in our case, this Poisson turns out that it usually is pretty close the majority of the time, which is rather nice. All right, so here's a problem for you to try. So please read through the problem, press pause, read through, and then try each of these problems on your own. All right, welcome back. So let's see how you did. All right, so the mean number of babies delivered per day should have been 5.1, and this was a trick question, I will be honest. In the year 2024, there were not 365 days, there were 366 days because it was a leap year. If you used 365, don't feel bad. Your answers should be very, very similar to the answers that I have, but just so you know, you should have divided by 366. All right, part B, they want you to find the probability that exactly 5 babies were delivered that day. So they used the mu and the 5, and they placed them into the Poisson formula, and they got 0.175. So there's about 17.5% chance that you're going to deliver 5 babies that day. Part C, no babies. This is unheard of. I have one of my best friends is a labor and delivery nurse, and she can tell you that there's never a day where there's 0 babies being delivered. So probability of 0 babies, plug in all the information, and you get 0.006. So you have a less than 1% chance that you're going to have no babies at work that day. So that doesn't happen very often. All right, so that is the Poisson distribution, works very well. And that ends our study of probability distribution. So please come back next time and we will start talking about a new topic in statistics.